children, today in this session number 66, we are going to discuss the remaining questions from brain teasers, that is first main B question to 9th main. Children, here B question we have, and the question is answer the following questions. How many times can the following figure be folded so that it is symmetrical? Here we have all the four sides given here, children. This is a figure they have given to you. Now you have to say how many times it can be folded so that it is symmetrical. If I am going to fold it vertically, then what happens? Each part in the right side is going to coincide with the left side. So we get one line of symmetry, and one more is the horizontal line. If I fold about the horizontal line, then what happens? The above figure is going to coincide with the below figure. Same in the case of, if I am going to fold it about the corners here, if I am going to fold it this way, then also I get all the parts below is going to coincide with the parts above. Same with the case, if I am going to fold about this line, about this corner, then if I'm going to fold it, I get this part is going to coincide with the above part. Same in case of the last session we have discussed, no, this one, children. Same way we get four lines of symmetry, or we get how many times can the following figure can be folded, means 4 times it can be folded so that it is symmetrical. Next question is, complete the figure so that the dotted line is the line of symmetry. This is very easy, children. Just you have to think that, imagine that a mirror is kept here on about this line. Okay, this is the line of symmetry if we think, and if the mirror is kept in this way, then this image is going to fall on the mirror. So what is the image you get on the mirror? That we have to draw. So you should be good artist than me. So you can do it yourself, children. Okay, you can do it neatly than me. Here is the, what do you say? The mirror image of the above figure about the dotted line. Next is, given the line of symmetry, find the other holes. Here is the line of symmetry, right? And if this is folded about this line of symmetry, then this dot is going to fall on where we have to find out, children. So we get almost beside this one. So this is going to fall on the here, and then this circle is going to fall somewhere here. So in this way we have to find the other holes, corresponding holes. We say this is for this hole is corresponding, and for this hole is corresponding. Then we have question number D. Draw the line of symmetry in the following figure. Children, if I'm going to draw about the horizontal line and fold it, we don't get symmetrical figures. But if I'm going to draw the line of symmetry about the vertical line, so what happens here? When I'm going to fold it, this first part is going to coincide with the second part. This is called as the line of symmetry. You can write it in your CW that this is the line of symmetry, children. Next, question number E. How many lines of symmetry are there in a regular pentagon and a rectangle and in a rectangle? Pentagon. What is pentagon, children? It is a geometrical figure having 5 equal sides. Right? Suppose this is a pentagon having 5 equal sides. All the five sides are equal. Such type of polygon we call it as pentagon. Now, how many lines of symmetry will the regular pentagon have? Means as many lines of equal sides, as many number of equal sides of a polygon, we have so many lines of symmetry. So if this is a pentagon, pentagon will have 5 lines of symmetry. This we have learned in the previous session. Then rectangle. If I'm going to draw the rectangle here, we know opposite sides are equal in a rectangle. Therefore, when I'm going to fold this rectangle about the horizontal line, we get a symmetrical figure. And if I'm going to fold about the vertical line, then also I'm getting the symmetrical figure. Therefore, these two are the lines of symmetry. But if I'm going to fold across the line or about the corners, I don't get any symmetrical figure. Therefore, the rectangle has got 2 lines of symmetry. 2 lines of symmetry you have to write, children. Then we have question number 2. How many lines of symmetry will the following have? Here are the polygons given to you, children. Here is a 9-sided regular polygon. 9-sided regular polygon means a polygon which has got 9 equal sides. So as many number of sides in a polygon, we have so many number of lines of symmetry. Here it is 9 means, so the line of symmetry will also be 9. If it is 10, then the lines of symmetry also will be 10. And a circle. We know already the circle has got infinite or many lines of symmetry. So I write infinite. An equilateral triangle. Equilateral triangle has got 3 equal sides. So 3 lines of symmetry it will have, children. A quadrilateral. Here the quadrilateral, we know quadrilateral is a figure where we don't get any side equal, children. Therefore, how many lines of symmetry we can expect here? We can expect no lines of symmetry in a quadrilateral. So I write 0. A rhombus. A rhombus has got, as we know, all the sides are equal in a rhombus, but it is little tilted, children. So when I'm going to fold it about like this, that means about the corners, this side or this triangle is going to coincide with this. If I'm going to fold about this line, then this triangle is going to coincide with this. But if I'm going to fold it opposite sides, about the opposite side, here we are not going to get a symmetrical figure, children. So in a rhombus, we can have only 2 lines of symmetry. Here, though all the sides of the rhombus are equal, okay, but the property of the rhombus is all the sides are equal. But when you are going to fold about the corners, they are going to coincide. See, about the corners I have folded. Here I showed no about the corners. If I am going to fold about the corner, then they are going to coincide. This way, if I am going to fold, then also they are going to coincide.
Okay, ma'am.
But you asked me if I am going to fold like this, isn't it?
Yes,
This
ma'am.
side, this way. So what happens? See, some of the part is left out. They are completely not coinciding.
Okay, ma'am.
Same with the case in the horizontal. If I am going to fold in this way, then also some part is left out. So the rhombus will have only 2 lines of symmetry. One is about the corner first, and then the second.
Okay, ma'am.
So these are the number of lines of symmetry for the given polygons, children. Next we have draw the lines of symmetry of the following figures. So we have to imagine when this figure is folded, about which line if you fold, you get this 2 dots. We have to imagine and draw the line of symmetry, children. So I'm going to draw in this way. I'm not using ruler here. It will be not visible for you if I'm using ruler here. So I'm going to draw the line of symmetry so that when I'm folded and punch it, I get this type of two holes. So I draw this line of symmetry. So after drawing the line of symmetry, you have to write it, children, that this is the line of symmetry. Now, about which line if you draw here, you get these two holes. So this is the line of symmetry, so that when it is folded, when you punch it, you get these two holes. So this is the line of symmetry. Then we have the third figure. So I will imagine if this is the center of this circle and I'm going to draw about the center point, then also here about this point, if I'm going to draw the line, then if you imagine and fold it, you get these two lines. If I'm going to fold in this way, again I'm going to get these two dots. So these two are the lines of symmetry. Children, then we have draw the lines of symmetry of the following figures. Here are the two figures given to you. You have to imagine and draw. Hope you are done already. So if I'm going to fold about this line, this side, right side, all the parts, if I'm going to fold it on the second part, the part is going to coincide. So I'll draw this first line of symmetry. Then the second line of symmetry, I'm going to draw about this, children. So this part is going to be folded. Then this part, this line is also a line of symmetry, because when it is folded this about this line, then also we get the symmetrical figures. So these are the three lines of symmetry. Then here in the figure you have, if I'm going to fold in this way, you know this part is going to coincide with the below part, and if I'm going to fold vertically, then also the right side part is going to coincide with the left side part. So these are the two lines of symmetry. Question number 5. In the following figures, the lines of symmetry are shown by the dotted lines. Here are the dotted lines, children. What you have to do is you have to find the other appropriate holes. As in case of here, in this question we have done vice versa. We were given the holes, we have to draw the lines of symmetry. But in question number 5, we are given the lines of symmetry, we have to find out the holes, corresponding holes we call. So if I'm going to fold this about the line, we get the hole here. This triangle about this line, if I fold it, I get somewhere here. And then circle, when I'm going to fold it about the line, so the corresponding hole must be here. And the fourth one, I have to fold it above part, so I get the corresponding hole in this square here. Next we have question number 6. Write 3 letters of English alphabet, each having one line of symmetry. That means here you have to write 3 letters so that the alphabet will have one line of symmetry. We know the first letter, that is A. You can write B. B is also having the B is the alphabet having one line of symmetry. Then we have C. You can write still more, but we want only 3 letters, children. Next we have to write the 3 letters of English alphabet, each having 2 lines of symmetry. You can show it in your CW, children, like having one line of symmetry by writing the big letters, and then you can draw the line of symmetry here. For the 2 lines of symmetry, I'm going to draw it here. If I'm going to take the letter H, so if you are going to fold vertically and horizontally, you get 2 lines of symmetry. Then the letter I, So vertically and horizontally. Then the letter X. So these all we have discussed earlier. Only we have to write the answers directly. No lines of symmetry. You have to write the English alphabet where we get no lines of symmetry. The letter G. G has not got any line of symmetry. Then we have Q, M, sorry, not M, P, N. We can write, children. So these are the three letters where we have no lines of symmetry. Then question number 7. L, M, N, T are the lines of symmetry. These are the lines of symmetry, children. L, M, N, and T. Now, of the line segments, XQ, and then PR, and then XY, XY, and RY. So these are the corresponding line segments for the given line of symmetry. Now, if XP is equal to 1.5, if XP is equal to 1.5 centimeter, then we have to find the length of the line segments here one by one from A. Question number A is PQ. What will be the line segment PQ? As we know, if this is the line of symmetry, L is a line of symmetry for XQ. So this line of symmetry divides the line segment into two equal parts. That is, if XP is 1.5 centimeter, PQ must be also 1.5 centimeter. QR. We have to find QR, children. To find QR, we know M is a line of symmetry. When such is the case, what will be if PQ, see, line M is the line of symmetry for the line segment PR. This is the line segment PR and this is the line of symmetry. If this line of symmetry is going to bisect means is going to divide this line segment into two equal parts, then if PQ is equal to 1.5, then QR must be also equal to 1.5 centimeter. Then we have question number C, children. That is RY. We have to find this length RY. As we know, this is the line of symmetry for which one? For XY. XY is the line segment and N is the line of symmetry for XY. So the line of symmetry N is going to divide XY into two equal halves. If XR, you have to find first what is XR, children. What will be XR? That the total of XP plus PQ plus QR will give you XR. XP 1.5, PQ 1.5, QR 1.5. Altogether, we get the 4.5 centimeter. That means from X to R, the length is 4.5 centimeter. What will be the length of RY from here to here? So this must be, XR must be equal to RY. Therefore, if this XR is 4.5, RY will also be 4.5 centimeter. This is question number C, children. PR. We want the length of PR now. Just what we do? We add the length of PQ plus QR. If I want PR, children, this is the length I need, PR. To find PR, we have PQ separately, QR separately. To get PR, we just have to add PQ plus QR. 1.5 plus 1.5. 2 times if you add 1.5, you get 3.0 or simply 3 centimeter. This is question number 7, children. Next we have question number 8. If the dotted lines represents the lines of symmetry of the given angles, find the value of X. This is the dotted line. We have to find the values of X, children. This type of questions we have solved in the worksheet. Now, as we know in an angle, if you draw a line of symmetry, suppose I had already told you, if this is 60-degree angle. Now, if I want to draw the line of symmetry, what is this line of symmetry called in an angle? It is the bisector of the angle. What does the bisector of the angle do here? It bisects the given angle 60 degree into two equal halves. So it will divide the angle into 30 and 30. The same way, keeping this in mind, we are going to solve x here, children. It is given here. This symbol represents 90 degree, we know. So totally it is 90 degree. This angle is 90 degree. Then find x means x will be half of 90. That is 90 divided by 2, which is equal to 45 degree. We know how to divide 95 divided by 2. 90 divided by 2. Isn't it? Basic division here. Or you can cancel here. 2 ones are, 2 fours are 8. 1 is left. 2 fives are 10. So 45 degree is x here. In the next question, complete angle, that is not complete angle, children. In this figure, the angle, full angle is given as x. We are half of the angle. When the line of symmetry is drawn, it is dividing the angle into two equal halves. So one half is 85. What about the full? Means what we have to do? X is equal to 2 times 85 degrees. So 2 times 85 will be 170 degree, children. Here we have to multiply by 2 because we have to find a full angle. Half angle is given, you have to find full means into 2 you have to do. Hope you understood this. Next is question number 9. Create any two mirror image of figures of your choice. Mirror images, any type of mirror images you can draw, children, on your own. So if I draw by drawing the line of symmetry, the same figure I have to draw it on the right side. So you must be knowing how to draw. So if this is the mirror image, you have to draw in this way in your CWs. One more is two mirror image you have to draw. So I can draw it in this way. So these are the two mirror image and this is the line of symmetry. So these are the two mirror images, children. You can draw the two mirror images of your choice. So in this way we have completed the brain teasers question in this session. Hope you understood well, children. Thank you, children.